In our previous video we found the equation of a tangent plane to question 4 of our exercise on tangent plane and normal line. We're going to find the equation of the normal line now. So remember, the normal line is somewhat similar to the general equation of a straight line, y equals mx plus c. Here now, what we have is y equals going to be gradient. The gradient function in this case is partial of z with respect to y times x, but in this case we use the parameter t plus y naught. The x and y are somewhat similar to it. X is equal to delta z by delta x, t plus x naught. Z is equal to delta z by delta z, delta by itself, times t plus z naught. Now we saw earlier that delta z by delta z is going to be a negative 1 due to the equation itself. Generally, if you're finding delta z by delta z, you get 1, right? Delta x by delta x, you get 1, and so on. But the way the equation is set up, if you, just a reminder, this is the tangent plane equation, the general equation. Now, if you should make everything on the same side and equal 0, you'd have to subtract this. And when you subtract it, you say minus z naught equals 0. But then you will ask, just like how you have a delta z by delta x in front of the x minus x naught and a delta z by delta y in front of the y minus y naught, what is the delta z by delta z in front of the z minus z naught? Well, you see it here. It's negative 1, alright? It would be negative 1, not positive 1. So we see that we could deal with this one first. Z is equal to negative t plus to z naught again. Negative 1575. Alright, so we could just say minus 1575. Now y is equal to, and x is equal to, x was what? Delta z by delta x at the point was negative 635. Negative 635 t times plus x naught was 5 and y naught was 4. So delta z by delta y at the point was negative 1195, negative 1195 t plus 4. Alright, so there you have these three equations. X equal negative 635 plus 5, y equals negative 1195 plus 4, z equals negative t minus 1575 is in parametric form. We could also write them in symmetric form, transposing each of them for t and then equating them. So in this case, t would be equal to x minus 5 over negative 635. In this case, t is equal to y minus 4 over negative 1195. And in this case, t is equal to, well, it would have been negative t is equal to z plus plus 1575. But if you want it to be t, you could consider these to be over -1, right? So all these now, you can remove the t and say x minus 5 over -635 is equal to y minus 4 over -1195 is equal to z plus 1575 over -1. So you have the equation now in symmetric form.